Hi Reza, it's Harlan, and this is my assignment 2 run through. So I just have my info here. So I'm going to start with the tennis. So I generated some basic data here. I went off temperature, wind speed, humidity, chance of rain, and the overall decision. And then for the model here, since our decision is a string, once I read the CSV into a data frame, I then select that decision and then replace with if we're playing, I replace it with a 1, and if we're canceling, I replace it with a 0. That way that the model can actually understand what's going on. And then I was playing around with different ways to display the data since we've used matplotlib before. And through some research, I found this Seaborn library, which is built off of matplotlib, which is pretty cool. So you can set up the Seaborn, but then still call the plt.show to actually run it. And it's way easier to set up. Like I just have a single line. So I think I'm probably going to be using this library continued on because I'm really happy with it. So then we get into the meat and potatoes of just setting up the model. So I get the X by dropping the labels and then get just the labels. So I got the features and the labels. And then I do my splits. So I split the training and test data between X and Y using the train test split from scikit. It wasn't specified in the assignment for this section, so I just did it at a 20% that goes to test. And then the regular old random state 42, so it all stays the same. I initialize the decision tree classifier and then fit the model on my train data. Then we go for a prediction here. And then our accuracy score. Again, all from scikit. From there, the assignment then asked for 3 new examples. So I just made another data frame with the new stuff in it, with some very obvious bad weather and good weather. So, you know, if it's -10 out, you probably don't want to be playing tennis. But if it's 33 and very low wind speed, maybe you will. So we're expecting a 0, 1, 0 or a false, true, false. Then we predict again on this new data and then show that. So I'm just going to run this. See how we're doing on time here. Okay. So I get this. We've got relation on one side. So we have all the features on one side compared to all the features again. So I'll just look at wind speed, for example. A higher wind speed and a higher temperature. It's this red section here, and this will be most likely not going out versus this we will be going out. Then we can see we have an accuracy of 100% and our predictions were true, which you like to see. No, I'm just going to move over here. So now with the COVID data, I started with 30 rows, but I was only getting 66% accuracy. So I doubled the amount of rows, and then my accuracy went up to 83%. So I kind of left it at that. I just figured that there wasn't enough for the model to make a good prediction, so I just added a bit more. I made the CSV with age, fever, cough, breathing difficulty, loss of taste or smell, and then the result. And then I scaled it from 0 to 2, 0 being you do not have the symptom, 1 being you have mild symptoms, and 2 having severe symptoms. So for example, this person over here has 0 of everything, or 0 of all the symptoms, so they're not going to be positive. But then higher levels of the symptoms, they're more likely to be positive. So that's what I kind of did with the CSV. And then the model is very similar to the tennis one. So we import it. I don't have to do anything with the CSV because I just made it all numerical. I put it through the Seaborn again, and then we get the features and labels. We train it, we fit it, and then we predict on it. So I'm just going to run this real quick, which should be the same here. So we get a little bit different data from last time, and that's just mainly because we're only dealing with 0, 1, and 2, so not that many options to make it sparse on the graph there. And then if we look at our output, oh joy, that went better. We got 94% accuracy. So that was the assignment. I'm a little bit over, so I apologize for that. But all in all, I've never used a decision tree classifier before, so that was something new to learn. But everything else I've kind of done before. The thing I learned the most from was just this Seaborn library. Anyways, I hope marking goes well. Take care, and thank you.